Good morning here everyone. This is yet another video about AK7735 audio codec here. So that we have here. So basically to talk about this, as we know previously I was trying to interface this audio codec chip with ESP32 actually. So here I have this ESP-32 TTGO board and this is interfaced with this AK7735 audio codec for which the device driver has been successfully written for ESP32 on ESP32 for ESP32 using ESP IDF IDE actually. So basically, I would be talking in this video. I would be talking more in more detail about the audio flow and the audio model that I have used, that I have programmed for this for the internal DSP of this AK7735 audio codec here. And basically, we will look like what it is actually and how the model has been designed actually. So to begin with, first let us look at the audio block diagram of this AK7735 actually. So here we can see that there are two internal DSPs of the inside this AK7735, and that is the best part about it. There are two DSPs actually, so you can program both these DSPs using a special tool that is provided by Asahi Kasei AKM actually. So basically we have used that tool to program these DSPs actually to design the audio flow model actually. So here we can see there are four I2S input channels that are being provided by this AK7735, out of which we have used one out of them. So basically we're using the one actually, the first channel actually. So one, two, three, four are there. So we have used the one, and here you can see the I2S lines are being configured for. So the I2S data is basically transmitted from this ESP32 using DMA over DMA to this AK7735 for playback actually. And the control of this the registers and all the other settings are being done using I2C actually. Using I2C lines have been used to program it. And the line out or the playback is being fed to the to the aux in of this JBL speaker that I have here. So the line out is going to the line in or the aux in of this speaker through which we are doing the playback actually. So what we are doing right now here is that we have this I2S lines actually. So we have configured the clock for a sampling rate of 48 kilohertz, and there is this crystal oscillator 12.288 megahertz actually, which is providing the master clock actually, which is set as 256 fs actually, a multiple of again a sampling frequency actually. So basically we are giving the digital audio. The digital audio is present inside this SD card actually. So using DMA over I2S actually, we are reading the file actually, the audio file, and we are transferring the data over the I2S buffer on DMA to the I2S channel that we have used of this ESP32, and that is being fed to this to AK7735 actually. So basically, the sampling frequency is 48 kilohertz for the playback, with the bit clock as 1.536 megahertz, and the master clock as 12.288 megahertz actually. So basically, this is going to the DSP actually. Inside the DSP, we have designed this audio flow actually that you can see here. It comes as these two inputs from SD in one actually, because this is from SD out, so this it becomes SD into this AK7735. And after that there is the 12 dB headroom followed by the volume element actually, and then it comes with a three-dimensional enhancer which has these different elements of low pass filter, high pass filter, gain settings and all that actually. So more about it is there in this document here, which I would not go into much detail to save time for everyone. So basically the enhancement, the speech processing and sorry, the audio processing and the audio enhancement, and the audio enhancement is done using this three-dimensional enhancer actually. So this has been set as this cutoff. It has got these different parameters here, which you can see here, the gain and the cutoffs. So basically we can control all these parameters using by programming the CDAM registers of CDAM that is shared with all these addresses that are being present for these all elements actually. So the file that is generated would be something like this. You can see here, this would be a generated file actually having all the bytes and bits. So basically, so this way it has been programmed in this, and the output goes to the SD to the from the output of this DSP. The DSP output of this, you can see here, the DSP output of this is shared on the common bus, and that has been fed to the SRC1 actually. It comes to this SRC1, and from SRC1, this DSP output can be fed to the SRC1, this program which we have configured and that we have generated it, and we have downloaded the program in this DSP memory of this AK7735 that has been fed to this that has been programmed and that is run actually. It is being run at the time of run up, at the time of power up of this DSP of this audio codec, and that is coming to this SRC1. And from SRC1, the SRC1 output is fed as input to DAC1, and from the DAC1 we are playing the output to this audio out, and this audio out comes to and plays to and comes as input to this aux in, and from aux in to this speaker, and it plays actually. So that is all about this audio flow. So let's see how it works actually. So if I start the audio, yes, we can see the playback is happening here. So if I try to change the frequency, the cutoff frequency, just see, changes the cutoff frequency. So more closely we can see what is happening here in the log. Next, if I change it to some gain actually, okay, we are changing the gain here. That's more or less about it. So thank you, thanks for watching this video.